Good morning, good afternoon, and good evening to all our viewers globally, and welcome to this webinar brought to you by IMarEST Offshore Oil and Gas Special Interest Group. It is a privilege of this group to actually have the host of our president, Yves De Leeneer, on the topic entitled Versatile Mooring System for Marginal Oil and Gas Fields. Yves is a naval architect, a European engineer, a chartered engineer, and also a fellow of the IMarEST, and he's the current president of the IMarEST. He's the owner of and managing director of DEEPBLUE, an engineering oil and gas company, a consulting company specialized in offshore projects. He's also a member of the advisory committee of the University of Newcastle for naval architects and architectures and marine engineering. For our global viewers, please note that this webinar is a listen mode only. So kindly use the Q&A charts box in the Slido. You have that in your link sent to you by email. And of course, provide your questions in that link. We will actually review those questions, and of course, the speaker will provide answers to your questions. Without further ado, I invite Yves to take it away. Yves?
Yes, Dr. Nimi, thank you very much. And thank you again. As president of IMarEST, I have to thank you for doing such a great job in Houston with the oil and gas SIG and reviving it. And I've seen, unfortunately, I haven't been able to come and see you, but I've seen what you've done. And thank you again. And thank everyone on the SIG. Your work is important and it's not unnoticed. So like Dr. Nimi said, I'm the managing director and owner of DEEPBLUE, offshore energy. I did about 8 FPSO conversions from naval architect to subsea manager to project manager. And I've started DEEPBLUE about 16 years ago and had several clients from around the world. And during my time, I was often asked by clients in Asia mainly, if we could get a simpler system, and especially cheaper system to produce oil. And so we looked at different things, and we started with one system, and then we upgraded it, and the second system was a bit better, until I did 5, 6, I think 7 systems in total. And so obviously we learned from each system, and that's what I want to present to you today, is a simple system that can be used and that has a proven track record for marginal fields. So like Dr. Nimi said, I'm president of IMarEST as well. So first of all, you're not going to see anything revolutionary here. There's nothing new. It's just application of existing stuff that exists. And normally, we can apply it with the following requirements: a short production field life, which is logic. That's why it's called a marginal field, because the field life of the field is short, and the production normally is between 5 and 10,000 barrels per day. If it were a longer field, 20-year and more production, then obviously there would be more capex available to produce with standard FPSOs and FSO systems. So this is really low capex, and also obviously you can't use that in 2,000 meters of water. So the deepest I've done is 150 meters so far. I'm not saying you can't go deeper, but it's around that range. I say low capex, but it's also low schedule. The last system we did, we signed the contract in the 1st of June, and by the 15th of July, we were producing. So the engineering was done in 6 weeks, and the installation. So nobody believed it could be done. Luckily, the oil company that hired us had extremely good people that could move very fast. And so we find a vessel, we find all the chains, we find the flow line and the riser within 6 weeks, and we were producing. So I'd rather have more time because it's less stressful, but it's just to let you know it's possible. So marginal fields. The way we've done it is that obviously you don't have an FPSO, so you still need to process the oil and gas. So most of my clients have used a jackup with production on it. And once they had that, they could send the stabilized crude and sometimes a bit of water, sometimes a lot of water, and we can talk about that later. And the key is that instead of buying a vessel, the client goes on the market, or we help them to go to find a standard trading tanker that is willing to stay a year, 2 years, maybe 3 years, or less than that, in a specified location. So it's a trading tanker. That's extremely important because trading tankers are under class and they remain trading tankers. So we call them temporary storage tanker, but which means they are just trading tankers, which means they remain under their class society and the class certificates. Everything is still applicable, which means we don't have a FSO notation or FPSO notation. It's all a standard trading tanker, and that's very important for the cost and for the speed at which you can develop this system. Now, trading tankers have emergency towing arrangements and winches. So we use those things as our main mooring points on the tanker. The idea is not to change anything, but that really depends on the location you're at, the environmental data you're going to have to deal with, and also the time you want to be there with your tanker. Obviously, if you want to be there 3 months as a temporary solution because your permanent FSO is delayed, but you can't delay production from a bigger platform. In that case, it wouldn't be a jackup. So you can, for a 3 months design, your mooring system has to be less robust than for a 2 or 3 year design. So ETA and winches are very important. The bigger, the better. Standard is on an Aframax tanker would be at least 200 ton ETA at the bow. Winches would be around 30-40 tons at the stern and at the bow. Then obviously you need something to bring the stabilized crude. So you need a riser, flow line over the seabed, and then a riser towards your vessel. And then obviously the mooring system, which can either be full chain or a combination and chain and buoys, and I'll show later how this combination is done. So yeah. So like mooring, I've talked about it already, but you're going to connect full chain to your ETAs at the bow. If you have, normally there's no ETAs at the stern, there is a towing arrangement, but you can't use that because, as I mentioned, you are still a trading tanker. So you can't use your towing arrangement at the stern and your tow wire at the stern for other things. So that has to remain there. If you want to stay more than a year, I would say, especially in Southeast Asia, we're dealing with monsoon weather, where you could end up in a yearly monsoon with wind speed up to 70 knots is quite normal here. So in which case we would like to add chain stoppers because we'd like to have the ETA at the bow. We'll use that, but then we'd like to have two lines at the bow and 2 full lines at the stern. We also use the winches for additional lines. And then, of course, we'll need Panama chocks, either existing or if we go with additional chain stoppers, new Panama chocks for high rating. We'll use the bollets on board the vessel. I'll show you that later. And yeah, so the possible additional equipment, if you want to stay longer, is chain stop, Panama chocks, and then, of course, tandem reinforcements required, and I'll go to that a little bit later. And if you want to do tandem offloading, you can add a quick release hook at the stern. These are standard. You buy them from Mampe and Pusnes and other companies. So basically, we're looking at chain, which can be found easily normally, because you're not following class society. Technically your chain system doesn't have to be class approved. So all you're gonna do is your chain mooring system becomes a terminal. It's not a permanent mooring system. Therefore, you don't have to follow class, which means you can have different sections of chain, you can connect them to each other, and you can make up chain in different sections, which is not allowed for permanent moorings, as you know. So this is an advantage. You can find chain around the world. If you're in a hurry, you'll find some. Panama trucks and chain stoppers. We're talking about OCIMF chain stopper standards. You find them around the world. Within a month, you can have them delivered wherever you want. The tandem quick release hook might take a bit longer, but that's okay, because you can do a side-by-side offloading, and I'll go later in that later. And then your deck reinforcements. I've used a company here, but there are companies all around the world that specialize in doing work on the tanker while it's either at anchor or it's still trading. Now remember, I want to do work for my chain stoppers if I want extra ones. So that's on the stern of the vessel, on the poop deck. So there's no oil and gas there. So you don't need to gas-free tanks and things like that. You're away from your standard cargo. And on the forecastle as well. So you don't need to gas-free your tanks. You might put a habitat around your welding system, pressurized habitat, and you need to follow some good HSE rules, and you'll have to go through the company HSE requirements and all that, but that's all doable. We've done it, so no issue there. So, yeah. So I'm sorry if it's a bit small. It was just to show you there was a platform here. We were a kilometer away. You like to be quite a bit away because it's a temporary storage tanker. So it can technically, it is able, in order to maintain its class and in order to not be classed as a mooring system, you have to have the ability to disconnect at any time. Now, the idea is not to disconnect, but if you design the system not to disconnect, then you start looking at 50-year, 100-year storms, which means you need to use a lot of, you need to have bigger chains, longer chains, you'll need bigger chain stoppers. So you're looking more or less as a permanent FSO. So the idea here is to say, well, looking at the environmental data, we guarantee that the system will work up to 90% of the time, let's say, over the year. And for the 10% of the time, you need to have a procedure to disconnect and all that. And that's why we use OCIMF chain stoppers and winches, so that with the equipment you have on board, you can safely disconnect, even if it's blowing 40 or 50 knots. You might need the help of some tugs, but tugs you always have in the field. So that's a procedure that has to be set up, and so you are able to disconnect if a really big storm warning is coming. And so you also need to have continuous metocean data and metocean forecast, which is easy to obtain. So in this system, we had two ETAs at the bow. So we had two full chains of 550 meters. And then at the stern, we didn't have ETAs, but we had winches and we had bullets. And I'm going to show you later how we set this up. And so we had full chain and we had a buoy. Then we had wire and wire again. So as I said, you need to be able to disconnect at any time. So your engine is still running. It's not an FPSO. So your engine, your whole crew is on board. And so your engine can push forward in order to slacken the chains at the bow so that you can disconnect them. And here, because they're connected with buoys, they're easier to disconnect. What we had also is that when bad weather was coming, captains say, yeah, no problem, I'll put my engine forward in dead slow, and that would reduce quite a bit of the load from the chains. So here you see a little bit more in detail the bow and the stern, and you have your two 204 metric tons OCIMF chain stoppers, your Panama chocks. So they were existing on the vessel. If the vessel is I think about, if they're more than 400,000 barrels, they normally might have two ETAs. So here we didn't have to change anything. We pull the chains in with the existing winches also. Now at the stern, it's more interesting because there we have one winch, two winch, three winches. So we made the best use of the winches possible. Now, the forward chains being 76 mm chain, and the ETAs can see about 500 tons, but the ETAs are 204 metric ton safe working load. So this was our limit. Our limit of loads on the forward chain is 200 tons. Now on the stern, you see here, if I'm going to take this winch here, it goes to a Panama chock, and you see our bullets are 68 metric tons, and our winch is about 40 metric tons. So in the front, we have 200 tons, no issue, that's plenty, but at the stern, we didn't. So what we had to do is go to, now, just to remind you, these chains here at the stern are, again, 200 metric tons, 76 mm, so 500 metric tons. Braking load, we have a buoy, and then we connected steel wire, and we doubled up our lines so that we could multiply the 60 metric ton at least by two, so we could see 100 tons on each system. So we had 2 times 200 tons limit on the bow and 4 times 100 ton limit at the stern. So that gave us 200 ton on each corner of the vessel, basically. So that's a side view. You'll see here full chain to the ETAs at the bow, and then there we have full chain, standard drag anchors, but because there's no point to use piles. If you're in the field that they already have piles, you might use them, but normally standard drag anchors are great for that. Going to a buoy, and then some steel wire, and then again some steel wire that is doubled up. So here's an example of an additional from another project, an additional OCIMF chain stopper. And so logically, we had to look, since we're going to pull 200 tons on it, we had to check the strength of the forepeak and did FEA analysis standard. And we added a new Panama chock for 200 tons. So yeah, that was another view of it. Oh, my apologies. There you go. So here's a little bit, a few drawings just to show how few things we did. You see here we had to put extra Smith brackets and extra, no, not Smith brackets, extra pad eyes. Sorry. You can see here we put an extra Panama chock, and this was a quick release hook because we wanted to go tandem. And as you can see, this was the standard towing system from the vessel. So we couldn't use that, but we could use its Panama chock. So we offset the quick release hook a little bit, and we use it so we could connect a shuttle tanker. Now the drawing above that you saw had four buoys at the stern. Now that was fine for a short period, but we had a project where we stayed more than about 2 years, and the client wanted the hassle-free. They didn't want to disconnect as much as possible. so as little as possible. So what we did is we added 2 OCI MEF standard chain stoppers, 2 Panama chocks, and obviously we had to increase the deck stiffness with extra beams below the deck. So we did it at anchor. None of the cargo holds had been gas freed, so that's the below the aft peak. So no problem. We did that within 10 days. We prepared the steel in the workshop. We got the drawings approved by ABS, and then once the vessel was at anchor, because we had to go fast, we worked 24/7 with teams and reinforced the stern. As you can see, we had to reinforce this part of the vessel as well. And yeah, in 10 days everything was done, painted, and ABS approved. So that's just to say that it can go fast, and because it's fast, you save money. You don't have to charter the vessel too long before you can start producing. But these are a few examples. These are some of the buoys that we made. So originally we had a pelican hook here, as you can tell, because the idea was to disconnect from the pelican hook. Unfortunately, we realized that it looks good in reality, but in operations, it's difficult to disconnect. So we went with a system where we disconnected from the vessel itself, and we just dropped the lines, and the vessel could sail away. Here's another vessel. You can see some forwards chains here. Here, there was only 1 chain going to the ETA, so we had to put additional buoys at the bow, and we had 4 buoys here at the stern. And then this was the latest one we did before. As you can see, well, it's a bit difficult, but I will send a copy of this presentation, so you will be able to look at it in detail. And we had 2 chains at the bow, and we added some more buoys as well. And here's a tandem vessel coming in order to offload. So this is all about the mooring. That's fine. Now you have a vessel that's stabilized, that is secure in a position. Of course, it's going to have offsets with respect to the weather, beam weather, etc. But you don't have any oil yet. So you need to get the oil from either an existing platform that's producing and is waiting for an FSO that is delayed, or if it's a real marginal field, often you have a little jackup platform and then a jackup coming with process equipment for a temporary period. So you need a small riser balcony at your jackup. Logic, you need to get the oil down. And what we did, we connected with the temporary storage tanker just at your standard midship manifold. So nothing fancy. You have your different reducers on board anyway, or you might get an extra one. So what we had there, we had the manifold. So because remember, you have to be able to disconnect. So we had a disconnectable system where we had standard flow line and riser, and then we used some heavy offloading hoses that we found, so that were buoyant. And in there was your standard offloading hose system. There was also a breakaway coupling in case something would go wrong. At least the riser would be disconnected from the vessel. This is your standard Gal-Thompson breakaway coupling that closes when it's parted. And on the vessel, for a standard disconnection, we had just a big manual ball valve with floats around it and a butterfly valve. So and then a hammer blow coupling. So it was a disconnectable riser with a breakaway coupling at the manifold here. So we had to come. This was one set riser, and then you have a connection here. So the flow line was, we found a flow line from that is not very heavy, because remember your field life is going to be 1 or 2 years, or maybe 3. So you don't need to go with your standard well stream, NKT, heavy duty FMC technique, heavy duty flow line and risers. You can use manually type risers. You can use maybe solid force risers. So there's a few risers that are less solid and they can be bought cheaper, faster, and that do the job. Now, of course, you need to be more careful with them, and it's good to have a spare in case something happens. But so far, all the systems that we've worked on delivered suitably. So also you have a standard system here. This is a bit of a weird system with those buoyancy modules. We didn't need any buoyancy module. The riser was buoyant. So by itself, it took this shape. What we did need is a gravity base with a tether to have some control over the motions of the riser. So here again, the field layout. Sorry. We have the tanker with the mooring system, and we tried to avoid because of the timing we had, the urgency, we had to install the riser before we installed the mooring. So we wanted to make sure that we were far away from our anchors with the riser. So instead of going straight, we kept different, and we connected to the platform. So like I said, we needed a tether system to control the riser. We called it a holdback clamp, and then tether and a big gravity base. So we designed, these systems are easy to design. So we designed it, we built it, and we installed it. That's the actual riser we did use on one of the projects. And then for the rest, we could use steel clamps to increase the stability on the seabed of the flow line riser that came in one section. But instead of steel, we used some concrete, some steel and some concrete, because as I said, we had little time. And also marginal fields, not much money. If you have concrete blocks, they're cheaper than steel blocks, and they'll do the job for your stability on the seabed. Like I said, some of our clients wanted us to put a tandem quick release hook and a system. Other clients said no, we don't have the finance for that. We just want to make sure we can do a side-by-side offloading, which is then your standard offloading. And remember, this tanker was about, due to Pacific, about 240 meters, so probably 600,000 barrels. Now, with a production of about maybe 10 max per day, that's 2 months, all right? And 10 is at the peak. So you can find a proper weather window to come in with your side-by-side tanker. It's not like with big FPSOs and FSOs, where you might do an offloading every week or every 10 days. Here you get about 2 months, maybe even more, to find the right timing to come alongside and do an offloading. This is just a bit of promotion of DEEPBLUE, because this is my bread winning company. The IMarEST is, as you know, is voluntarily. So I'm very happy to be the president and very honored to be the president of IMarEST, but I need to do a little bit of publicity as well. And then these are all the countries where we've worked, even the USA, and when I mean not me work, but where DEEPBLUE had projects. DEEPBLUE follows ABS, ISO, and yep, that's it for me. So if you have any questions, Dr. Nimi, I'll give it over to you, and you can read them out if there are any.
Yeah, thanks so much, Yves, for this interesting presentation. Yeah, quite insightful. There's so many lessons learned here, especially when it comes to marginal fields and how we can actually, exploit most of these methods so that we can actually commercialize these fields more. Yeah, I think on questions, basically, for our speakers, If you have any questions, those who are actually attending live, can you please, put your questions on the Slido link, which you receive on email. You can click that link there, and of course, ask your questions. Yeah, that will go a long way to really help us to address any concerns and any questions you want to really ask Yves. But one question basically I think that come to mind basically is the mooring systems and also the tankers, can they be refurbished, and be used on existing fields or transferred to other fields?
Yeah, so that's why we call it versatile, because basically your chain is existing, is there, your buoys are there, and you can disconnect. So all you need is an anchor handler to pick your chains up and move them to another field. Now the only thing is that the environmental data, the soil, well, the soil might be different, but normally you wouldn't design this because when we talk about marginal, there's two approaches here. It's marginal in its production, it's marginal in its available capex, and often is marginal because of the available capex in the time you have to create the system. So you don't want to design in detail. You will design in detail, but you're not going to fit your equipment based on your design very specifically. So you'll see which anchors are available right now from either Vrijhof or MarEST or Bruce, which make drag anchors, and you'll say, well, I need to be producing in 3 months' time. Let's find the anchors. So you're normally going to end up with anchors that are oversized for what you need. So, and the chain, like I said, is about 500 metric ton braking load. So you like to follow the OSIMF rules for mooring systems where you have a safety factor of 2. API RP2SK reduces that safety factor depending on dynamic analysis results and all that. But if you don't have much time, and because the tanker world and the oil and gas FSO FPSO world is rather different, and the tanker people they will follow the OCIMF book where it says safety factor of 2. So you can show them with all kinds of dynamic analysis that you're following API RP2SK, or you're following POSMOR from DNV, and that it's suitable for FPSOs and FSOs. They won't like it. And the other thing that normally they don't like is a captain doesn't like to have his vessel connected to something. He likes to be free, so he can go wherever he wants. So it takes quite a bit of explanation and convincing sometimes with the vessel owners to say, no, this is extremely safe. We had one captain on the same job. We switched over vessels at one point because one of the vessel owners changed double the charter rate after 3 months, and so we said no, that's not good. So we found another vessel, and the first captain was not feeling comfortable, and that's maybe why the double charter rate. The second captain that came in was much nicer, and he said, hey, he called me and he said, Yves, can I put my engine in forward and see how much I can pull on this thing? I said, yes, by all means, you're not going to break anything. He said, yeah, I say 10, 20, 30 tons, 40 tons, whatever you think, by all means. And he did that. He went forward, he went aft, and he was so happy because he said, look, I've pulled the vessel about 40 tons forward, 40 tons aft, and we moved about 1.5 meters. So he was really happy that he realized that the mooring system was solid. Remember also, the chain looks very small compared to the size of a tanker. And when it's blowing 60, 70 knots and you got 4-meter seas, people tend to say, well, is this really working? And so having that test done by the captain was really good. And so, yes, to answer your question, the system can be reused, and that's why and it's the ID that be reused. We had a client, like I said, that moved it 3 times, 3 different fields, about a year and a half for each field. They changed the vessel for the third field, but the same system was used. It's a bit more difficult with the riser system because they're more fragile than chain. But technically, if the riser system is fine, you can reel it back onto an installation vessel and reinstall it, no problem.
All right, that's good. That's good. So when we look at these systems, basically, what lifespan are we looking at in terms of if we need to redeploy these systems, on a marginal fields? What lifespan are we looking at basically due to the depreciation of these materials?
Well, as you saw in my presentation, we limited the loads on each corner of the vessel to 200 tons. Now, this was 76 chain, 560 tons maybe is the breaking load. So, of course, you have to take into account the corrosion of the chain, which rule of thumb is 0.4 millimeter per year. So you need 200 tons with a safety factor of 2. That's 400. You have 560 available. So that's so I need to know and look. But I think with 0.4 mil, you're probably 10 years or more than that in your chain before you get to the limit. And even then, like I said, you have a very high safety factor of 2, which you normally don't need on mooring systems. So you could discuss and prove that you can go with longer than 10 years. Well, 0.4 mil times 10 is 4 mil. Top of my head, 72 probably 500 tons. So I would say maybe 15, 20 years. Now, I never looked at it from that point of view because the client always wanted it for a short period. But also we bought 76 chain because it's a standard chain you use on rigs also. And so even if you have second-hand 76 chain and your marginal field is over, you'll find a buyer to buy it. No problem.
All right. That's good. So for tankers, basically, what do you think would be a key challenge for operators, deploying these mooring systems and also for major tanker like the FSOs and also FPSOs? Yeah.
But if I go to this now, you said the design life, so that was for the full chains. Your equipment, additional chain stoppers, they follow the class maintenance and then the vest standard maintenance. What will deteriorate more are your lines here, because they're gonna bite into the Panama chocks, and they will. So we always had a full set of spare lines on board. So that's one thing I would do, and we also had a check on the angle. So we wrote a procedure so that the crew would go around every 12 hours and look at the angle of the lines. Because if you have one system that chain that breaks, which is always possible, you won't see it. So you can only see it with the angle, the departure angle from the Panama chock. So when you say design life, these items will have to be changed, and you need spares on board. So I would say you change them every year, or you change them after a big storm, where you see that the system has been loaded quite a bit. We also put grease here. So you remember, you're still a normal tanker, and you're working with your Panama chocks quite a bit, and so you need to look after them. That was to go back to your design life. Your other question was, what's the challenge? Now, the challenge for the tanker owner is to realize he's going to be stuck, and he has to be comfortable with that. And like I said, we had a captain that didn't like it, but he didn't look at the system. He didn't try out the system. And then 3 months later, we had a different vessel with a different captain, and he asked me, can I pull on my mooring system? I said, yes. And he was extremely happy because he realized he's not going anywhere. And as a captain, he has the feel for his vessel. He knows what kind of weather he can be stationary in, with what kind of power on his engine. And so he understood that he became a mooring, he could help the mooring system really well if he needed to. And at the same time, that the mooring system was extremely solid from his point of view. So the challenge is to have tankers accept the situation and also allow them to do reinforcements on their forepeak and on the aft peak. So you might have to pay a bit extra in day rate, in charter rate, and sometimes they want you to take it away when after the job. The more smart ones, they realize that they could use that same tanker on another marginal field, and they could get a good day rate for it, because it means they already have extra Panama chocks, extra chain stoppers, extra deck reinforcements, and they've already have experience with operating it. So that's a bit the situation with tanker owners.
Okay, that's fine. Yeah. So looking at the commercial aspect of these fields, because one of the key challenges is to increase production, and of course increase return of investment. You know, what do you see as a major challenge when it comes to the reliability and of course the safety of this system for deployment?
Well, you need to find a jackup that is available with a process system on it. Now, there's not many of them, but there are process systems available. Now, remember, this is maybe 10,000 barrels max, maybe 15, but not much more than that. So these are small process systems. So each project I did, it was all done. Let's charter a jackup. Let's find a process system that we put on it. Let's spend 1 or 2 months in a yard to implement the whole thing. So one is the jackup, and I don't deal with that. That's normally the oil companies that themselves are going to do that. And then, so I deal more with the tanker and everything. But so you need a jackup with a process system on it. Then you need to build a small riser balcony, and that's okay. One of the fields I've been in did it a bit differently. They took a barge and they put the processing system on the barge. So there we didn't have a jackup. We had the monopile platform, and so we were sending 3-phase oil and gas through a pipeline to a barge with processing systems on it, and some small accommodation to do that. So the advantage of a jackup is that it has all the firefighting HSE requirements are already there, and you just need to do additional stuff for your processing system. So once that's done, but I know jackups were dirt cheap a few years ago in Asia, at least. Probably the price has changed now, but you could buy a jackup for very cheap. And then you want a good tanker. And so the simplest and easiest way is to go with a bareboat charter, and then with a crew charter as well. So you go on the market, you find a tanker, and if you're not happy with the crew or the managers or the owners of the tanker for whatever reason, you disconnect, you find a new tanker, and you switch over the tankers. That's also possible. So you have that possibility also. Or if you say, well, it was supposed to be here for 6 months, and it becomes longer than 6 months, and the tanker owners doesn't want to be there for more than 6 months, because remember, your mooring system changes depending on the length you want to be there. So if you want to be there longer, you say, all right, we're going to install chain stoppers at 2 at the bow, 2 at the stern, Maybe they already have two. Maybe there's only one. Then you need to put an additional at the bow, two at the stern. And we're still going to use the buoys, but at least we have 4 chains, full chains, connected to the tanker. And you can do that while the tanker is on at anchor, and then the tanker sails into the field, and you swap over the mooring system. We did that also. So you need to find a jackup. You have to find probably a second-hand process system or a cheap small process system. The rest is a bit of piping on the jackup. You need your HSE. You need to do, of course, you need to do a safety plan and all these things. You do a hazard, a HAZOP. You make sure everything's okay. You follow the oil company rules. You follow the international rules, and then so that's number one. And then number two, you need to find a ship that you can charter, which follows the full tanker classification rules and all that. So from a ship's point of view, you don't need to change too much, because they're just loading oil, which is what they're made for. So the crew knows what they're doing. You might add a few additional marine crew because you want to have a 24/7 lookout. So you might add a few extra people on board. You might have a CRS on board. You might have some additional people. But nothing very different and very fancy. So you mixing what you know from oil and gas rules and regulations and standard ways of operating with what you know from tanker, and you mix both so that your safety, you don't delete the quality, you don't diminish the quality of your safety. I mean, we were the last project I did. I'm not going to say the name, but it's a big American oil company. So it was Houston was going crazy when I was proposing all this, and so they really, I spent days and days explaining and thinking, and because it was different, they were looking at it from an oil and gas FPSO FSO point of view, and so they say, how, no, we can't do that. I said, look at it from a tanker's point of view. You know, tankers are safe. They go around. I say, here we're not going even anywhere, so it's even safer than traveling, than moving from one port to another with a tanker. We're not moving anywhere. We have anchor handlers. We have supply vessels to help us. So there was also a thing, if the weather became faster, or if we had a huge squall, we had permanent towing arrangements, so that the supply vessel that was permanently in the field could support us, could help. So we never needed it, but all these things were in there as an extra safety measure as well.
Yeah, thank you so much for that answer. One of the viewers here is asking about what's the meaning of ETA. Could you probably expand on that?
Emergency towing arrangement. That's a chain stopper that is normally 200 tons safe working load, that has that can see 76 mm chain, and that's on every tanker at the bow. In case they have a complete blackout, they can pull that in from an anchor handler or a tug or another tanker that's come and save them, so they can connect a 76 mm chain with a tow wire. So that's standard on every tanker at the bow.
Okay. Yeah, so yeah, that is good. We really appreciate that. Yeah, I think one more questions we do have.
So remember, the key is that you don't become an oil and gas facility. You are a trading tanker, and that makes a huge difference in the rules and regulations. It makes it simpler, but because it's simpler, the safety factors have to be higher, which makes sense. If you don't go in more depth into the engineering and the design, you have to increase your safety factor. That's why for following OCMF systems, your safety factor always have to be 2, like while while API, where you go in details, your safety factor. The other question, Dr. Nimi?
Yes, the other question basically is the STT normally included in the OI safety case or position outside the exclusion zone? If in safety case, is there a hierarchy or CMOP?
Yep. So if we go with the STS, so the side by side to side offloading, that's what I think you're asking. Yeah, we had to get it all approved by Houston, and the marine part of the oil company, the marine department looked at it, got it all approved. We flew in mooring masters from the oil company to do it. We had the vessels. Before that, we did a HIRA, obviously with everyone. We did all the requirements that the oil company wanted, and then the side by side happened in the field. So we didn't disconnect and go outside. I remember we looked at that, but we looked on the we were on the sorry. So we were on the starboard side, and we were a kilometer away from the production. We stopped the production. I don't remember if we flushed the line or not. And I mean, people were a bit stressed because, as you see, there wasn't much. It was about 17 meters difference between the two. I don't remember if the vessel was exactly that size, but I remember they asked us, well, what happens if we use a similar type vessel? The reason why we've looked at that instead of disconnecting and going away is because reconnecting would take probably about 2-3 days. So we would have to disconnecting the crew could do by themselves. They'd been trained, but reconnecting we needed to bring in a new installation crew. And so from a timing point of view, from a financial point of view, we've looked at that, and we would have lost. The problem we had is that it's not the loss of bit of production. In this project, it was a huge platform that was a gas production platform, and we were receiving the condensate, and they only had about 3 days of empty pipelines where they could send the condensate before they had to stop production. And if they stopped production, they would get penalties from their gas, the gas contract they had with the government. And so they've looked at it, and we've looked at both situations, and we found out it was probably a smaller vessel we went for. We found out that this was the safest, easiest, and most effective situation. So we brought in the side-by-side fenders. So all that, I don't remember if they bought them or if they rented them, but yes, there was no issue. Another company wanted to do the tandem. So there, because they stayed longer, they thought it was safer to have a tandem offloading instead of a side-by-side. One offloading we did also was when we swapped over the tankers, we timed it in such a way that the tanker that was there full time was full. So we disconnected it sailed away, and then we did the offloading side-by-side away from the field. But so it really depends on I would say, on the oil company, on the country you're working in, and on who gives the go-ahead with respect to the results from the HIRA of the project. So you might be in Europe, probably this won't be allowed. If certain oil companies might not allow it, but then other companies and in other countries this might be allowed. but I'm not the master mariner, so I don't. It's not my forte to know. I just know we've done it in different ways, and all the safety requirements were followed, and it was found to be suitable. Thank you.
Yeah, thanks, Yves, for this response to the questions provided by our viewers. We really want to thank you immensely for making this possible for us to really have this presentation. And of course, for the work put into this good research and projects. Yeah, so we want to call it up here. And of course, we want to thank our global viewers, those who really attend in person. And of course, for those who will be viewing this afterward, because it's going to be recorded, So we really appreciate you making the time, to click on this link and of course to go through this webinar. This is how the offshore oil and gas actually provides thought leadership and of course insights to our members and to the industry. We'll be more than happy to really have our viewers, to continue to click in here and of course attend our webinars. If you have any questions, please feel free to really reach out to Yves, the speaker, and he'll be more than happy to respond to your questions. We really thank the IMarEST too in making it possible for us to have this platform, and of course to share our thought leadership with our global viewers. So with this, we want to ask Yves to say his final comments and closing remarks.
Yes, thank you, Dr. Nimi. Yes, so I wish to thank all of you for having taken an hour in your busy schedule, and please join Nimi's group in Houston or wherever you are. As you say, we do work at times so that it's 11 o'clock here in Singapore for me, and it's 10 in the morning for Nimi, and so wherever you are, we try to reach you, and we try to provide information and technical knowledge, which is at the end of the day is what the IMarEST role is, and we try to do our best to give that to our members. So thank again for listening. Thank you.
Yeah, thank you, Yves, and of course, thank to our global viewers. We hope to see you more in our next webinar. Please watch out, and of course, do register to attend our webinars. Thank you, and have a great day.
Thank you.